Page 3 now of 7.4. Again, we're calling this 7.4 most. We're covering most of the topics in 7.4. We'll come back for the leftovers at another time. We're trying to get boringly good at factoring. Let's recall what we did a couple pages earlier. Factoring is breaking something down into its most basic multipliers. Into its most basic multipliers. Another way to think of that would be what we're finding is we're undoing the multiplication or the foiling or the distribution. Okay. And we're going to become boringly good because we're going to do the same steps every time. We're always going to check for the GCF. Always. First, we're going to check for it. Always. Easy to fall into a bad habit of several problems in a row not having a GCF, and then you kind of forget to check for it. You think, oh, there won't be one. That's when it sneaks up on you. So we're going to try to train ourselves to always check for the GCF first. After we do that, we ask ourselves how many terms, okay? The first thing, and it's either going to be 2 terms, 3 terms, or 4 terms. And we are covering right now the idea of 2 terms. We're going to look at this one first. This is in the 7.4, our 7.4 most lesson right now. It will either, and these are the special forms, it'll either be the difference of squares, the difference of cubes, or the sum of cubes. Remember, there is no such thing. There is no formula for factoring sum of squares. It does not go any further. 3 terms we'll come back to. First, we want to deal with 4 terms. So that will be when we go back to hit the second part of 7.1. We're doing things a little bit different order of the book. So because I prefer to teach factoring this way, 2 terms first, then 4 terms so that we can use what's called factoring by grouping. And then we come back to 3 terms. A lot of times 3 terms is presented as more of a guess and test or a puzzle, and this is where it can be very, very frustrating for students. At least that's been my experience when I hear students tell me. So the way I teach it is we get really good at the special formulas. We get really good then at 4 terms, factoring by grouping, and then we learn how to convert 3 terms back to 4 terms so that we can then use the factoring by grouping. And that will be what we cover in 7.2 and 7.3. Totally fine if you have another method for doing factoring. Extra good if you remember factoring was kind of clicking for you and you just need to unrest a little bit. Don't feel like you have to change how you do it. What I'm presenting is for those of us who factoring has been a struggle in the past and it felt really unbearable, difficult, too much of a unknown how to deal with it. So this is just one way to kind of solve that. So the special forms that we've still been working on it, you're going to want to memorize these. Now we've talked about this before. How do you get something memorized? How do you get it to where it's there for you in long-term memory when the test comes? And we say it and write it every time you use it. And that means you're actually seeing it and hearing it, so that you hear it and see it, and that's going to mean that you're going to learn it 4 times as fast. Okay, so it will start to feel kind of, ugh, I have to write this out every time. Well, only if you really want to have it ready for when the exam comes. You've taken an exam now, you know what that feels like. If your grade was not where you wanted it to be, ask yourself, what happened? Did you have to memorize something that you didn't have memorized in long-term memory, or you thought you had it memorized but it blanked on you when it came time to take the test? If that's the case, let's look at how you're trying to memorize something. And this is a method that works for most people. Say it, write it, and of course then you hear it and see it. Every time you use it, you're going to get that into your long-term memory. Okay? So what are the 3 special forms here? Well, you've got difference of squares, we called it DOS. You have these in your notes just a couple pages earlier, but again, it doesn't hurt to write again because that helps get it into long-term memory. Difference of squares starts with the version a squared minus b squared, and it factors to a plus b, a minus b. There's difference of cubes, DOC, so DOS and DOC. Difference of cubes, a cubed minus b cubed. Difference means subtract. And this is a pattern that you need to memorize. You've got your a and your b, then you've got your a squared and your b squared in the second longer trinomial 3-piece, and then a times b is in the middle. And then the signs have this pattern where you go the same sign as what you see, opposite of what you see. In this case, same would be minus, opposite would be plus, and then always plus at the end. And that pattern gets reused again, same, opposite, always plus. That SOAP pattern gets used for your SOC, your sum of cubes. So that's where you have a cubed plus b cubed. And again, the factoring for that, you don't have to do any thinking, just plug in the pieces from the memorized formula. A and b, a squared and b squared, notice it's exactly the same as the one above, and even AB is the same. All that's different are the signs, but you still use this same pattern. SOAP, same, opposite, always plus. Same as where you start, in this case plus. Opposite of what you start with, in this case minus is the opposite. Always plus is always plus. So this is a plus b, a squared minus ab plus b squared. And that's the formula for the sum of cubes. And of course, the sum of squares, there is no formula. Squares is not factorable. You have to stop at that point. So there is no such thing as sum of squares there. Okay, so we're going to factor using the formula for the sum of two cubes or difference of two cubes. So we practiced. Oh, and I need to move the paper, so I'm going to finish this video and then we'll come back up for the bottom of the page.